So electricity, system of resistors in, we have different ways by which we can connect the resistors. What is the main function of the resistor? It is to regulate the current flowing through the circuit. The required value of current can be got by connecting the resistors in series, parallel, or in varying combination. So where do you find the system of resistors working? You find it in a regulator. It's a combination of resistors in series which help in regulating the speed of the fan. We regulate the speed of the fan using a regulator. So it is nothing but a system of resistors in series. So there are two ways by which you can connect the resistors. One is in series, one after the other. The other one is the parallel connection. Okay, so resistors in series, now they will be doing this activity now. This year, I think we have this for the practical activity also. So you have three resistors connected in series along with a switch, a battery, and an ammeter. Ammeter is used for measuring the current flowing in the circuit. So where do you find the series of resistors, series circuit? You find it in decorative serial lights. So this is how the connections are made in a series circuit. So the potential, can you see? Is the screen visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. This is good enough, no? Or you want me to enlarge it? So you have derivation of an expression for resistors in series. So this is the diagram wherein you have R1, R2, R3 connected in series with, and it is also connected to an ammeter in series, and you have a voltmeter measuring the potential difference across the battery. So whatever be the potential difference applied across the battery, that is going to split among the three resistors. So you call the potential difference across each resistor as V1, V2, and V3. So in a series combination, what is constant?
Current.
Current is going to be constant. So same current will flow through all the resistors irrespective of what the values are in a series circuit. So what is going to be constant here? Current is constant, but the potential difference will vary across each of the resistors. The potential drop across each of the resistor will vary. So the total potential difference is given by V is equal to V1 plus V2 plus V3. So applying Ohm's law, we can express V in terms of I as the same current flows through all the resistors. Current remains constant in a series circuit. So how do we represent them? So V1 can be written as I into R1, where I is a constant. I into R2 and V3 is equal to I into R3. Thus, V1 plus V2 plus V3 is equal to I into R1 plus I into R2 plus I into R3. Or V is equal to I into R1 plus R2 plus R3. So if Rs is the equivalent resistance or total resistance in the circuit, then V is equal to I into Rs. So we get IRs equals I into R1 plus R2 plus R3, or Rs is equal to R1 plus R2 plus R3. What is important about the combination of resistors? So this is the expression you get for. So the sum of all the resistances will be more than the individual resistance. So the total resistance in series circuit will be greater than the sum of the individual resistances. The equivalent resistance is equal to the sum of the individual resistances. It's always greater than the resistance of each resistor. This is known as the maximum effective resistance. Current through all the resistors is going to be the same. So these are all the important points regarding a series circuit. The potential difference across each resistor is going to be different. Can you do this? 3 resistors of 5 ohms, 10 ohms, and 15 ohms are connected in series with a 12-volt power supply. Calculate their combined resistance, current that flows in the circuit and in each resistor. Can you do this? So what will be the total resistance? R1 plus R2 plus R3, 5 plus 10 plus 15 gives you 30 ohms. Using Ohm's law, I is equal to V by RS. So you get the current to be 12 by 30, which is 0.4 amps. So what is going to be the current flowing through each of the resistor? It is going to be the same, which is 0.4 amps itself. So the current flowing through each of the resistor will also be 0.4 amps because current remains to be constant in a series circuit. Clear? Is it clear?
Yes, ma'am.
Yes, ma'am.
So we'll go on to some questions here. Why do we not use series combination of collecting electrical appliance in household circuit? Why don't we combine the resistors in series? Or why don't we combine the appliances? See, each appliance is a resistor. It is going to have its own resistance. So why can't we combine a bulb, an AC and a fridge or a TV in series?
If once one appliance get affected, means the others will also get switched off because same
Very
current
good.
is going to
Yes.
be throughout.
Yes. Then, yes, agreed.
Each appliance need different voltage, and that also
Yes.
can be considered.
Each appliance will require different current also, isn't it?
Yes, ma'am.
And
Yes.
because the same current will flow through all the three appliances, they might not even function. So you are normally, we would have seen this. Sometimes when we switch on the AC, the light will become dim, isn't it? So this happens. And sometimes even if one appliance is going to get fused, the entire circuit will be broken. Now, can you do this? Draw an electric circuit consisting of 3 resistors of 5 ohms, 4 ohms and 3 ohms connected end to end along with a battery of 24 ohms, a plug key and an ammeter. Can you do it? Calculate the current flowing in the circuit. What is the current flowing in the circuit? What is the total resistance? 5 plus 4 plus 3, right? 9
Yes,
plus
ma'am.
3, 12.
Yes, ma'am.
Total voltage is 24. So what will be the current?
2 ampere.
2 ampere is correct. So it is going to be 24 by 12 V by R, which will give you the value of I, which is 24 by 12. Okay. Shall we go to the next question?
Yes, ma'am.
You can do this now. So what is the total resistance here? RS.
90, ma'am. 90 ohm.
RS is equal to 20
90.
plus
90
20
ohm
plus
20 plus
20
20 plus 10.
plus 10. Sorry, the voltage is, the net is not proper, it happens. 1 minute. $20
Plus 10, ma'am.
plus 10. So this comes to 90 ohms, right?
Yes, ma'am.
90 ohms. And V value is given to be 9 volts, right?
9 volts.
So
Yes,
what
ma'am.
is I? I is equal to V by
V by
RS,
9 by 90 ohm.
which is
9
9
by
by
90.
90. 1 by 10.
1 by 10,
10.
1 by 10.
0.1 amp, right?
Yes, ma'am.
Now they are also asking you to find the potential difference across the 10 ohms resistor, right?
Yes,
So
ma'am.
V is equal to I into R. I here, same current will flow through all the resistors. So
All the
0.1 into 10, which will give you 1 volt. Which will give you 1 volt. One volt is the potential difference across the This is 1 amp, 0.1 amps. Clear? Any doubts?
No, ma'am.
No, ma'am.
Shall we proceed?
Yes, ma'am.
Yes, yes, ma'am.
Oh. This is all with the series. We'll go on to the next slide. So now we are going to discuss resistors in parallel. So when you connect the system of resistors parallel to each other, what will be the effective resistance? A parallel circuit has two or more paths for the current to flow through. Voltage is the same across each resistor in a parallel circuit. So this is how a parallel circuit. So these are the resistors, and this is the voltmeter which is connected across the three resistors, and they have a common point here. Okay, and this is in turn connected to a battery and a key. And you're going to measure, have an ammeter across each of the resistor. So what is going to remain constant here?
Voltage.
So the
ma'am.
current that is flowing in us, one moment. What is going to remain constant in a resistor, system of resistors in parallel?
Voltage. Voltage. ma'am.
Voltage. Voltage, ma'am.
What is going to be different here? Will the current be different? The ammeter readings be different? Or it is going to be the same?
Different, ma'am, for each connection.
Yes,
Different.
the resistor current flowing through each
Current
resistor will be different because the requirement of each resistor is going to be different. So this is how the current is going to be split when it flows through a parallel circuit. Can you
Parallel
see?
circuit.
The current
Yes,
that
ma'am.
is flowing is going to get split among all the three resistors like this. Okay, so the current, the total current in the circuit will be the sum of the individual currents flowing through each of the resistors. So if I1 is the current flowing through R1, I2 is the current flowing through R2, and I3 is the current flowing through R3, then I total will be I1 plus I2 plus I3. So now let us derive an expression for resistors in parallel combination. So at applied potential V produces current I1 in R1, I2 in R2, and I3 in R3. So what is going to be the total current? The sum of the individual currents. So I1 plus I2 plus I3 gives the total current. Applying Ohm's law, instead of let us express I in terms of V, why do we express I in terms of V? Because V is a constant across all the resistors.
Resistor.
Yeah, so I1 will be V by R1, I2 will be V by R2, and I3 will be V by R3. So then I will be V by, total current will be V by RP. Thus, V by RP equals V by R1 plus V by R2 plus V by R3, or if you take V out to be common, you get RP is equal to 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Important points regarding parallel combination. The reciprocal of the equivalent resistance is equal to the sum of the reciprocal of individual resistances. So 1 by Rp will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. And always the equivalent resistance is less than the resistance of the least resistance. This is known as minimum effective resistance. The current from the source is greater than the current through each resistor. So the total current will be greater than the individual currents that flow through the resistors. Potential difference is going to be a constant in a circuit. So let us calculate. Can you do this? Can you do this? So 1 by R effective is equal to 1 by R1 plus 1 by R2 plus 1 by R3, 1 by 2 plus 1 by 5 plus 1 by 10. So R effective will, if you take the LCM, it is 10, you will get 8 by 10, or effective, R effective will be the reciprocal of this, which is 10 by 8, 1.25. Isn't it less than the least resistance? The total effective resistance here is 1.25, which is less than the least. Which will give you 8 amps of current. Okay. Supposing you do this for series combination. If you connect them in series, can you calculate the total current? What will be R total if 2, 5 and 10 are connected in series? What is it going to be? Are you all able to listen? Hear me?
Yes, ma'am. Yes, ma'am.
So
ma'am,
if
we
you're
are
going to
hearing you.
connect it in series, what will be total resistance in series? What is it going to be? RS will be equal to
17.
2 plus 5 plus 10. Yes or no? 2 plus 5 plus 10, that will give you 15, 17 ohms, right?
17. Yes, ma'am.
17 ohms. Can you calculate for the same voltage what the current is going to be? 10 by 17.
17.
10 by 17 will give you what is 10 by 17?
Zero 0.588, ma'am.
0.588 amps. But what is the current available in parallel? For the same system of resistors, when they are connected in parallel, you get 8 amps of current. But when you are connecting them in series, the available current is also going to reduce. Very much, whatever available current is there that is going to flow through all the resistors will also be insufficient. Whereas here the available current is going to be more, which will get split among the various resistors. So that way, connecting them in parallel is actually disadvantageous than connecting them in parallel is advantageous than connecting them in series. Okay, so you can explain the difference between the advantage of or the advantage of parallel over series using a problem like this.
Okay.
Which type of combination of different resistors will the current flowing through each of the resistor remain the same? Please answer. Which type of combination of different resistors will the current flowing through each of the resistor will remain the same?
Series.
Series. Can you do this? Two resistors with resistances 5 ohms and 10 ohms respectively are to be connected to a battery of potential difference 6 volts so as to obtain a minimum resistance and maximum current. Find their values. How do you need to connect them?
Parallel.
So what is the answer you got?
Resistance 3.3 volt.
1 by 5 plus 1 by 10. Right?
Yes, ma'am. Yes, ma'am.
Yes. So it will be 10 by 3. You will get 3.3 ohms.
Yes, ma'am. 3.3.
3.3. And potential difference is 6 volts. So what will be the current? You want me to work out or you know?
1.6
6 by 3.3. 1.8.
1, ma'am.
1 point. Can't hear you. What is the answer? 6 by 3.3.
1.81, ma'am.
1.80.
1.80, is it?
Yes, ma'am.
Amps. Okay. So this is going to give you the least resistance and maximum current. Are you all able to follow, or you want me to work it out? Anybody wants me to work it out?
Yes, ma'am.
Or you're
Yes, ma'am. Yes, ma'am.
able to follow, isn't it? Yeah, can you do this? A wire is cut into 3 equal parts and then connected in parallel with the same source. How will its resistance and resistivity get affected? How would the total current and the current through each part change? So that is the sum. Can you do that? So you have a wire. Let us take the resistance of the wire to be R. Okay, it is cut into 3 equal parts. So let the resistance be R. It is cut into 3 equal parts. So what will be the resistance of each part? R by 3 plus R by 3. Each part will have a resistance of R by 3. Right? Now these are connected in parallel. These are connected parallel like this. Okay. They are asking you to find the total effective resistance. Since they are connected in parallel, it will be 1 by Rp equals 1 by R by 3 plus 1 by R by 3 plus 1 by R by 3. So what will be the total effective resistance? This is going to be 3 by R plus 3 by R plus 3 by R. So the new resistance, or 1 by Rp is this much. So Rp will be, this is nothing but 9 by R. This is 9 by R. So Rp will be equal to R by 9. Rp will be equal to R by 9. So the resistance, the question is, how does the resistance change? So the resistance becomes 1/9 of the original value. The original value of the resistance was R. Now it has become R by 9. So the resistance has reduced 9 times, right? Understood or not? So what will be the effective resistance? The final new resistance will be is reduced by 9. What about the resistivity? Will the resistivity change?
No, ma'am. For a material, it is.
Resistivity will not change. Okay. Resistivity. What is the factor which is going to affect on resistivity? What is the factor which affects resistivity?
Temperature, ma'am.
Temperature alone and nature of the material. So what are the factors which affect resistance? R is equal to proportional to L, inversely proportional to the area of cross section, or R is equal to rho L by A, where rho is the resistivity of the metal, L is the length, A is the area of cross section of the wire. Correct. So these are the factors, and apart from this, you also have temperature which is affecting the resistance. Now the question is, what happens to the resistance? What happens to the resistivity? That part of it we have answered. Now the question is, what is the current, right? What will happen to the current flowing in the circuit? What is going to be the current when we are all connected in series? Initially, the current value will be, I will be equal to V by R, the original current, total current. Now they are connected in series. So the new current, I will be equal to, we'll call it I dash, V by R by 9, or this will become 9 times the original value of I. So the current is going to increase by 9 times. What happens to the resistance? It is reduced by 9 times. Whereas the current in the circuit will increase by 9 times when they are connected parallel to each other. Is it clear? Is it clear or not? So what is the change in the current? Current will increase 9 times, whereas resistance will reduce by 9. It will be 9 times less than the original value. Clear? Any doubts?
Ma'am, if for each resistance we have different current value, no, ma'am. So that shall we take R by 3, ma'am? No.
Yes. The total current is going to be 9I, right? So what will be the current through each of them? 3I, 3I, 3I. Because the resistances are all constant. So each current, the current flowing through each resistor will be 3I. 3I, 3I. The total current will be 9I. Is it clear? So I1 plus I2 plus I3. So here it is going to be 3 times
Yes, yes, ma'am.
I, 3I plus 3I. When you add all of them, you will get 9I. Clear? So this
Yes,
kind of problem is there in your text, but they've asked you to find the ratio of the old resistance to new resistance. They haven't asked about, they haven't asked about the current change, resistivity change and all. So you can get questions like this, wherein cut it into 4 equal parts, 5 equal parts, questions like this can come. Okay. Have you taken down?
Yes, ma'am.
So we will go on to this. We did, I think. No, we'll do this. Can you do this? So how are the resistors connected? They are connected in parallel. So 1 by Rp equals one by R1 plus 1 by R2 plus 1 by R3. So what is this going to be? 1 by 90. Can you tell me the values?
1 by 90, 1 by 45, 1 by 180.
Plus 1 by 180.
180.
So what is the LCM for 180?
180. ma'am.
So 2 plus
7 by 180.
4.
4 plus 1. So it will be 7 by 180, or RP will be equal to 180 by 7, right?
Yes.
What have they asked you to calculate? The potential, the current, right? I is equal to
V by R.
V by RP which will be 9 volt by 180 into 7 on top. So 9 will go in 180, 20 times. So it will be 7 by 20. What is the answer?
0.35, ma'am.
35 amps. Okay. So this is how you calculate. This is completely system of resistors in parallel. So we discussed system of resistors in parallel and system of resistors in series. Now we will try to find system of resistors. See, this is how the parallel connection is. Series parallel connections are like this. Can you see? What is the disadvantage of series? But the bulbs will glow dim when they are connected in series. When one component fails in the circuit, then all the other components stop working. It is easy. Advantages. We have never come across advantages of series. In this case, it is easier to switch on or off all the appliances connected together. With one switch, you can turn them on or turn them off. It is safer as less current flows through the circuit. Whereas in parallel circuit, more current is going to flow. It is used when hundreds of thousands of bulbs are to be used together. And so that same current is going to pass through all of them. That is the serial lights. This is parallel circuit. This is parallel circuit. So even if one appliance fails to work, the other two continue to work. So what are the advantages of parallel combination over series combination? In parallel, each appliance gets the full voltage. One appliance is switched on or off, others are not affected. Parallel circuit divide the current through the appliances. Each appliance gets proper current depending on its resistance. In a parallel combination, it is very easy to connect or disconnect a new appliance without affecting the working of the other appliances. That is why in domestic circuits, all the connections are made parallel to each other. Can you find this is a combination of resistors, series and parallel. Can you find the total effective resistance here? What is the total effective resistance? Can you find that?
Yes, ma'am. Four, ma'am. The answer is 4, ma'am.
4, is it? So 1 by 4 plus 1 by 4. These two are parallel to each other. So 1 by 4 plus 1 by 4 will give you 2 by
2 by
4.
4.
So
1
this
by-
combination is also going to give you 2 volts, 2 ohms. So 2 plus 2 will give you 4. Correct?
Yes, ma'am.
The potential of difference, yeah, same sum only. Can you do this? Is this the way you connected? 5 ohms, 8 ohms, 12 ohms in series, potential difference to be measured across the 12 ohms. So voltmeter is connected parallel to the 12 ohms resistor and each 3 cells of 2 volts. So total voltage will be 6. 2 into 3, 6 volts. Correct? Did you draw like this?
Yes, ma'am.
How do you calculate the total resistance? Sum of all the individual resistors, which will give you 25 ohms. So I is equal to V by R. V is equal to I into R. So V is 6 volts, R is 25, I will be 6 by 25, 0.24 amps. We are asking you to find the voltage across the 12 ohms resistor. So same current is going to flow through the 12 ohms resistor also. So 0.24 into 12 will give you 2.88 volts. That is the voltage across the 12 ohms resistor. Clear? Can you do this? Nowadays, they ask a combination of resistors quite often. So, it is, what are the two in series? RS is equal to 40 plus 20, yeah? First case.
Yes, ma'am. 40 plus 20.
Yes, 40.
This is, we call it RS1. What is RS2?
70 plus 20.
70 plus 20. So this is going to give you 60 ohms. This is going to give you 90 ohms, right?
Yes, ma'am.
So they are parallel to each other now. So 1 by RP will be 1 by 60 plus 1 by 90, right? So what's the LCM? 180. 3 plus
2. 5 by
5 by 180. Which is going to give you what is a, so RP will be
180 divided by 5.
180 divided by 5. So what's the value? $36 ohms. Right? Now this is in series with total, this is going to be in series with 20 ohms. And what is the other one?
50.
50, ma'am.
Yeah, 50.
50. Yes, ma'am.
So what will be the total resistance? 106. Correct? 106 ohms is going to be the total effective resistance of the combination of resistors. Clear?
Yes, ma'am.
Can you do this?
46.6.
46.6 ohm, ma'am.
46.67 ohms,
Six.
correct. So this will be 1 by RP, which is 1 by 20 plus 1 by 20 plus 1 by 20 gives you 3 by 20. So RP will be 20 by 3, which gives you 6.67. So 20 plus 6.67 in plus another 20 gives you 46.67. Can you do the third one? See some. 1 by 4 plus 1 by 6 plus 1 by 12. So what is the answer?
2 ohms, ma'am.
2 ohms.
2 ohms. Now what is it for 5 and 20 parallel?
Ma'am.
4, ma'am. 4
Four.
ohm.
4.
So now this, and this are in series. So what will be the effective resistance? 1 plus 3 plus 2 plus 2 plus 4. Correct?
12. Yes, ma'am. 12, ma'am.
Yeah. 4, 5, 6, 7, 8 plus 4, 12 ohms. Is it clear how to solve such problems when you have combination of resistors? Yes?
Yes, ma'am.
What next topic is heating effect of electric current. The flow of electrons generate heat in the conductor, isn't it? Why? Because of the resistance. More, see, there is an activity here. The heat that is produced is enough to even burn a pencil. So much of heat is produced. Okay, why is it burning? Because of the graphite. The graphite, the good conductor, there offers resistance and converts it into electrical energy to heat energy, which burns the pencil, which is made of wood. So how do you derive an expression for the amount of work done when electric charge moves against a potential difference, which is denoted by V, is given as W is equal to V into Q. Then V is W by Q. We know that V is IR, Q is I into T. So we get I is Q by T. And finally, we have substituting the values. We get I into R into I into T, which becomes I squared R into T. Here, H is the amount of heat produced and it is expressed in joules. So Joule's law of heating, the equation is H is equal to I squared R into T. So this is how you derive the expression for Joule's law of heating. If it has to be expressed in terms of ampere, then it becomes V squared by R into T. So it is directly proportional to the square of the current for a given resistor, directly proportional to the resistance for a given current, and directly proportional to the time for which current flows in the circuit. So this is the problem. Can you do it? A heater of resistance 300 ohms is connected to a main supply for 30 minutes. If 10 amps of current flows through the filament of the heater, then what is the heat produced in the heater? So Q is equal to I squared R into T. Substitute. You are asked to, you can express the heat generated. If you express time in seconds, you get the answer in joules. If you express time in hours, you will get it in watt-hour, kilowatt-hour. So substitute the value 10 squared into 300 into 30 minutes has to be converted into seconds. SI unit of time is seconds. So you get so many joules of energy. Can you do this? Find the heat produced when a current of 0.5 amps is passed through a coil of resistance 200 ohms for 5 minutes. H is equal to
15,000 joules, ma'am.
I squared R into T. So this is I squared is 0.5, the whole square. R is 200, right? Time is how many minutes?
5 minutes.
5 minutes into 60, because we are going to convert it into second. So this becomes 0.25 into 200 into 5 into 60. So this becomes
15,000.
20 into 2 into 5 into 60. So what will you get?
15,000. 15.
15,
15,000 joules.
15,000 joules or 15 kilojoules.
Yes.
So this is how. See, when you express time in seconds, you get the answer in joules. Okay. I think that's all we have. Heating effect is okay. Shall we go to the next concept? Practical applications of heating effect, I think you know. Heating effect, iron box, electrical heaters. Why do we use alloys for making heating elements?
High melting point.
Do not oxidize easily.
Oxidizing.
They have higher resistivity than the metals from which they are made. And they also don't get oxidized at that high temperature. Okay.
Yes.
The electric bulb is also based on heating effect. We use tungsten, which has a high melting point and high resistance. So it converts most of the electrical energy to heat energy. And it also has the capacity to retain the heat and emit it as light. And why are the bulbs filled with nitrogen? To prolong the life of the filament. If it is filled with air, at that high temperature, it react with oxygen in air and get oxidized. So the life of the filament will be reduced. Electric fuse is another application. And when unduly high current flows, it will melt and break the circuit. It should have a low melting point, high resistivity. Okay. So I think these are all the benefits of a fuse. So high resist, the heating effect is used in making heating devices which have a high melting point, fuse which has a low melting point. So application of the concept. Calculate the ideal fuse for an electric heater of 2 kilowatt electric power when operated at 220 volts. So P is equal to VI, I is equal to P by V. So 2 kilowatt can be converted to 2000 watts by 220, which gives you 9.9 amps. So what should be the ideal fuse for suitable for such a current? 10 amps, slightly more than the current that is flowing in the circuit. So this kind of problems they can ask. What is the fuse rating of the circuit? Like that they can ask. So since it is 9.09, you need to have a fuse having a rating slightly more than that. Okay. Now we will go on to electric power. P is equal to V into I. Same thing like what I taught you. So power is the rate of use of energy, consumption of energy, energy by time. How much power does an electric circuit consume? Charge Q across a potential difference V requires, what is the work done? V Q into V, V into Q. So instead of work, let us substitute V into Q by T, which will give you V into I, because Q by T is I. Using Ohm's law, power can also be written as I squared R when they are connected in series and V squared by R when they are connected in parallel. So these are the other expressions for power. Power is V into I. Power is also equal to I squared R, which is also equal to V squared by R. So you have higher units of power, energy. Power is measured in watts. And the power bill, normally the electrical bill that we get, it is kilowatt hour. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. So convert kilojoules into joule, kilowatt into watt. So it will become 1000 watts into hours into seconds. 60 into 60 gives you this. So they given the power rating as 1200 watts. Time usage is 0.5 hour. What will be the energy consumed? Two ways you can express. This is all in joules. If they ask you to express in kilowatt hour, it will be 1200 into 0.5. What will be the answer? 600? 600 watt hour. That when converted to kilowatt hour will become 0.6 kilowatt hour. So multiply power rating. Power into time gives you the energy consumed. What is the power dissipated in a 27 watt resistor when the current is 0.135 amps? So power is equal to I squared R. So it will become 0.35 amps the whole squared into 27. It is not watt, it is ohms actually, 27 ohms. So this will give you the power as 0.49 watts. What is the power dissipated in a 100 watt resistor with 5 volts across it? So 5 into 5, V squared by R becomes 0.25 watt. You can do this, then refer the worked out example. Power is equal to 750 watts. Voltage is 220 volts. So P is equal to VI. I is equal to P by V. That is what is done here. So it will be 750 by 220 gives you 3.4 amps. And its resistance. P is equal to V squared by R. R is equal to V squared by P. So it will be 220 into 220 by what? 750. That will give you this many ohms as the resistance. An electric motor takes 5 amps from a 220 volt line. Determine the power of the motor and the energy consumed in 2 hours. So voltage is given, current is given. So P is equal to V into I. 5 into 220 gives you 1100 watts. Energy consumed is power into time. So time is given for 2 hours. So this is nothing but 7200 seconds. So this is the amount of energy consumed. Okay. This was the content. Yeah. Can you do this? Compare the power used in a 2 ohms resistor in each of the following circuits. So see, in series, you have to consider the total resistance only, no? Even though they are particularly asked for 2, you have to consider the total resistance. So what will you get here? I is equal to 6 divided by 1 plus 2, which is 2 amps. So I squared R will give you. Here you take the resistance of 2. So it becomes 8 watts. It becomes 8 watts. Can you see? They are in series. So when they are in series, you add the 2 resistors. Okay? Able to follow? And when you're calculating I squared R, take R to be 2. So you get 8 watts, not 12. What about here? 4 ohms. Are they connected in parallel? The voltage across the 2 ohms resistor will be 4 ohms. So here you can straight away use V squared by R. So V squared here is 4 into 4 by 2. So it becomes 16 by 2. Again, it is 8 watts. So the power consumed by both is in the ratio 1:1. Clear? It is not 12. Did you understand why it is not 12? Okay. Power problems, they do ask, what is the difference between resistance and resistivity? So you have 3 conductors here. Length L, area of cross section A, length 2L, area of cross section A, length L, area of cross section is double that. So what are the factors which affect resistance? R is directly proportional to length, inversely proportional to the area of cross section. So R is equal to rho L by A. So these are the factors which affect the resistance of a conductor. So what is resistivity? Resistivity is defined as the resistance offered by a conductor of unit length and unit cross-sectional area. SI unit is ohm meter. It depends on the nature and temperature of the material. It is independent of length and cross-sectional area of the conductor. So these are the values of the resistivity of various materials. It is also unique for a given material. Why are alloys used? They do not get oxidized. They have high resistivity. So that is why they are commonly used in heating devices. High resistivity and high melting point makes it being used in the thing. Copper and aluminum are generally used for electrical transmission lines. They have good conductors. Higher the resistivity, lesser will be the conductivity. Lower the resistivity, higher will be the conductivity. Will current flow more easily through a thick wire or a thin wire? How will it flow? Will it flow easily through? It is directly proportional to length. So longer the length of the wire, more will be the resistance, right? And when connected to the same source, which case the current flow will be more? Thick wire or thin wire?
Thin wire.
What is resistance inversely proportional to? Area of? What is it inversely proportional to? Area of cross section? So 1 by A. So thicker the wire, lesser will be the resistance, and current will flow more easily through a thicker wire.